Okay, so now we are looking at differentiation and integration of transform of the Laplace differentiation and integration of Laplace transform. Okay, so we know that fs is equals to the integration from 0 to infinity of the canal function f of t dt, right? So what we're going to do, we're going to differentiate both sides with respect to s. So differentiating this side, we're going to have d, df, ds, which is the same thing as f dash s, right? Which is equals to d ds of the integral f of t dt. But then here we are differentiating with respect to s, we are integrating with respect to t. So these two are independent. That's why we are going to use this derivative to differentiate the exponential function, because the exponential function inside the integral is the only one that varies with s, right? So we are going to differentiate the canal, which is the exponential function, with respect to s. So this is d ds of e minus st f of t dt. So when you differentiate an exponential function, what do you get? When you differentiate e to the power minus st, we are going to get the integral. We are going to get, this is going to be the integral. So we're going to get, if you differentiate eax, so the derivative is going to be eax, right? So the same thing here, this is going to be minus t e, because we're differentiating with respect to s, so t is a constant. So minus t e minus s t, right, times f of t dt, isn't it? So I'm going to factor out minus, I'm still left with the integral. So I have e st, and then I'm going to have t f of t, just going to group these two. So now when you look at this, now it's like it's again, you're finding the Laplace transform of this function. If I can just say whatever is in the square bracket, let this be g of t, right? So this is the same thing, finding the Laplace of g of t. And we know that the Laplace, this is, remember, it's negative, so this is going to be the Laplace of whatever is in the square bracket, right? So it's going to be t f of t, right? So we're saying this is equals to what? This is equals to f dash s. So now we have created a relationship here. So now we can see that the Laplace of t f of t is equals to minus f dash of s, taking this minus this other side. So this is very important. We're just shown by the differentiation of this Laplace transform. So what we did here, we differentiated both sides, right? And we're differentiating with respect to s, so this is the part that is going to be differentiated. And if we differentiate that, you're going to get this, right? And then I just factored out negative, and then grouped t times f of t, right? And then I said from here you can recognize these. You can recognize this, right, as the Laplace transform, right, from the initial equation. So this is the same thing as the Laplace transform of the function, our new function, which is t f of t. So That's why we get this relationship. It's very important. And from this relationship, you can also develop the inverse. So here, the inverse of f of s is equals to minus t f of t, right? Because if you take the inverse, if you take this side is going to be the inverse, right? And then you're going to be left with t f of t. Then the minus you can divide, so it's going to come this side. So this is another relationship that we have. So you need to remember these two. These two equations, because they're going to be useful. So let me just go through a simple example with this one. So if you have, so where we are going to apply these two. So example 1. So let's say we are tasked to find the Laplace of t cos 2t, right? We are tasked to find the Laplace of t cos 2t, right? So first of all here, you can see that this is the same as this, right? So we are going to use the first equation. So we are going to use this equation, right? Because the layout, so we are given this is the same as this. So we are using the first equation. So, and then now, one thing that you have to do, inside the braces, you need to determine which is f of t. So your f of t is equals to cos 2t. You just solve it the way as I'm solving it. So f of t is equals to ft. Then the question is, then if you know f of t, then what is f of s? And we have done this before. We know that f of s for cos is what? This is going to be s squared plus 2 squared, which is 4, right? That is very important. So now remember, if we are given this, we need to find what? We need to find this part, right? So what we need to find now? The derivative of the Laplace transform. So we need to find f dash s, right? So f dash of s, we're differentiating this, isn't it? It's going to be what? It's going to be, this is equals to, if we are differentiating that is going to be s squared plus 4, right? Times 1 minus, this is going to be times 1 minus minus s 2s, if I'm not mistaken, s2s, then all of this is s squared plus 4 squared, using the quotient rule. So you have found the derivative of f of s, so you can just simplify this to be, so this can be 4, right? So 4 minus s squared over s squared plus 4 squared, right? So then from here, now you know the derivative of f of s. So now you can rewrite this as t, right, cos 2t is equals to minus, that's what the formula says, minus f dash s, which we have already found. That is what? That is 4 minus s squared over s squared plus 4 squared, right? So this is going to be s squared minus 4 over s squared plus 4 squared. That's it. So that's how you can use this relationship to find the inverse, or in this format. Simple. And you just go, once you have to determine, first of all, you have to determine f of t, as we did, and then find the Laplace transform of that f of t, and then differentiate the Laplace transform of that f of t, and then equate these two, and then you're done. So that's how you can go about solving this one. So now let's find another one that we can use to apply the second equation. So the second equation normally works it always works when you are given an inverse trig function, logarithmic function. You have to use this one. Let me make an example. So let's say now we are finding the inverse. When you find the inverse trig, inverse of it, the inverse of, let's say, tan, inverse trigonometric function tan s. So you can see that this is what? This is in the form of f of s, right? So be very careful. So this is, right, in the form of f of s. So then what do you do here? You recognize that f of s, what is f of s? Is what? Your f of s is equals to tan inverse of s, right? And then remember, with this formula, you need to find the derivative of f of s, not just f of s, the derivative of f of s. So we need to find the derivative of this, right? We need to find the derivative of this. So f dash s is going to, when you find the dx of tan inverse of f of s, you remember that this is equals to f of s 1 plus f of s squared, right? So you use the same principle here. This is going to be 1 over s squared plus 1, right? So, and now we know this function. So now we can work with this, right? So coming back to our formula here. So now we have Laplace inverse of 1 over s squared plus 1. Now we have transformed this trigonometric function into a form that we know, right? So we can find this. This is equals to what? This is going to be, so s squared plus omega squared, right? You can see the denominator, isn't it? Is in that format. The denominator is in that format. So automatically, if this is omega, right? So we are going to get what? We are going to get sine. So this is just sine. We are going to get sine here. So this is sine t, isn't it? We are going to get sine t. This is sine t, right? So now this part is equals to sine t, and we know that also this part is equals to what? Is equals to this, right? Which means sine t is equals to minus t f of t. Don't be confused by that. So now we were evaluating the first part of the formula, right? We got that is what? It's f of t is sine t. So which means sine t is equals to this part, isn't it? So that's an easier way of seeing this. So now we just have to make f of t the subject of the formula. So f of t is equals to minus sine t over t. So this is how you do it. You are given f of s. Now you end up with f of t, right? So that's how you can evaluate using the differentiation of the Laplace transform. You just need to remember these two formulas that you can apply depending on the type of function that you have. If your function is displayed in this format, you use the first one. But if you are given an inverse trigonometric function like this one, and then you're finding the inverse of that inverse trigonometric function or the inverse of an logarithmic function, so you are going to use the second one. So that is very important. So on another video, we are going to look at the integration of Laplace transform.